It's a daytime but no solar output at all, as you can see. In today's video, I will describe one of the common problems that I faced with my solar inverters, and that is the fault within the MPPT cards, or in particularly the IGBTs as it is in this case. In my observation, it is a very common problem in almost 50% of the cases. Although there can be many other things that can attribute to cause such faults, but if the solar system is properly installed with all the safety measures in place, the chances are very low for all other cases like overloads or many other things that can cause faults, and mostly it is the MPPTs that get faulty. The top reason for a faulty MPPT card is, in my opinion, is of cloudy weather, when solar output is very low, while the electricity demand kept high, putting some extra strain on the MPPT card with a high current flow through the IGBTs that cause them to malfunction, as it is the case over here. Long story short, I'm not going into the details like disassembly or describing or testing each section or components over here, as it will get very lengthy. But an inverter with the faulty MPPT card may show fault 09, fault 52 or 53, or no fault code at all, as it is the case here, where it behaves in a way that there is no solar input at all, like it is at the night time. But the solar wires show very high amperage, and both in a way that that both solar input terminals are short circuited, as it is the case over here. Remove the bus wires as I'm doing now. These are the bus wires, and this is also another connection wire. This is also another control wire, and this is a 20 volt wire, and this is a control wire from the Voltronic base card, and another wire to the relay. So remember all these connections, and all the wires and connections should be exactly as they are. This is a Voltronic control card. Now this is a temperature sensor, and this is the inductor coil. So simply remove this MPPT card now and thoroughly inspect all the connections and SMD resistors. This is the top view, and you need to test most of the other components as well, and also inspect the data sheet. But in many cases there is IGBTs that are faulty, and I have done a thorough inspection. Now this is the inverter section. IGBTs, as you can see, they are all in perfect position and nothing is burnt, and everything looks perfectly all right. So after the visual inspection, I can verify that there is nothing wrong with the other components, and everything else is perfectly fine, and it is only the IGBTs of the MPPT card that need to be replaced or corrected, and there's no other signs of burning. So let's come to the MPPT card over here. If I inspect over them, this is the solar input wires that show short circuit connections. Maybe this is the PF capacitor that can be faulty, but I have checked it is not. Maybe the shunt, it is also shunt resistance was okay, and all the way things goes to the IGBTs. These are IGBTs. The middle one, that was faulty. At the left side there is a dual rectifier. As you can see, it should also be correct, and I found that it was okay. From the back side, I have inspected all the other SMD resistors from their dataset values, and everything looks perfectly fine, and no other sign of burning other than this IGBT. Maybe this chopper was faulty, but it was also correct, and it was not faulty, and it was okay. And maybe this IGBT or this IGBT. Now let's test the IGBTs with the multimeter. Put one probe on the gate and other on the source or drain. They should be isolated, but as you can see, they are connected, and it shows that gate is shorted with both the drain as well as the source. So it means this IGBT is faulty. And now inspect the second IGBT. Put one probe on the gate and it show open level, and also on the drain it also show open levels, means the gate is isolated, means this IGBT is okay. Now both IGBTs are in a parallel. You can see that both the collector and emitters are connected in parallel, means both show signs of shortness. That's why, because they are working in parallel. So you need to remove both. Since markets were closed and I was unable to find the MPPT PCB card of an inverter air conditioner, and it has an IGBT, as you can see. I have checked its data sheet. It was placed over here, so I have checked and verified that it can, although it was not compatible with it, fully compatible, but still can serve the purpose. I have simply removed this IGBT, and all other components except one IC was faulty, so this faulty PCB may fulfill my purpose. And now of the IGBT, now putting everything in place as I'm doing now, putting the solar wires, also the bus wires, positive and negative should be correctly placed at their points, and other pins also should be placed as I'm doing it now. This is a positive wire, this is a negative wire, and let's connect them. And also this 20 volt wire, and also this 20 volt wire should be placed as it is. This is a control wire. Put it at its place, and you need not to mess everything. Now let's verify all the connections and all the pins, and everything should be okay. And it is also taking, and as per the clamp on meter you can see it is taking 6 amperes, and in the past it was taking more than 20 ampere, but there was no solar signal, means there was completely shorted. And currently I am running in SOL mode, not the SBU mode. So let's see other the parameters. If I see the input line, it is taking around 3 amps, while at the output line, if I see, it is actually taking 7 amps. Means since it is very cloudy over there, so it's very much okay. So I have removed the fault. For temporarily I'm not putting a lot of load on this inverter, but still the fix has been done and it is running correctly, and also charging my batteries. So that's all.